Okay, welcome everybody. Hope you guys had a good spring break. I know it was not what you were expecting, but I hope you got to relax a little bit. But now what we're going to do is we're going to start off with our new unit. This is our Earth unit. We're going to start off with the layers of the Earth, the layers of the Earth, and how they relate to each other. So the first learning target is I will be able to draw comparisons to all the layers of the Earth and how they relate to each other. Okay, so what you're going to do is you're going to get this slideshow, and the slideshow is going to be on Canvas. And what I'm going to have you do is I want you to take notes. Okay, so here is the first assignment. You're going to take notes on the slides, and as you're going to do this, there's going to be a couple videos. Okay, I'm going to have two videos of me, and then also a video of somebody else that will be discussing in more depth, a little bit more depth as far as the Earth's interior. So what I want you to do is I want you to take a picture of your notes. And when you're going to take a picture of the notes, you're going to download that picture and then you're going to put it on Canvas. That's going to be the submission for this assignment today. Okay, so what I want you to do is go ahead and get your notebook out and then a pencil, and you're basically just going to take notes as you're doing this. This is going to help you retain the information a little bit more. Okay. Now this is going to then lead up to a final, I don't want to call it a project, but what I'm calling is a one-pager. Okay, and this one-pager will be due the next day. Okay, so one thing I want to talk a little bit about is that we're going to be doing 2 days. Okay, so it's red day and a blue day, and then we're going to have another two red and blue day, and then on Friday we're not going to have anything. Okay. On Thursday, though, every Thursday, I will be doing a Zoom meeting, okay? Now, then when we first start off, I'm going to have Zoom meetings a couple times just to get familiar with it, so you guys are familiar with it, okay? So let's go on to the next thing, okay? What I'm going to do is each one of these slideshows that I'm going to put together, I'm going to try to present a verbal explanation of these to give you a little bit more detail. Okay, a lot of you guys are going to want to hear what I have to say, and so I would listen to the video. The video is going to be linked on this slide right here. Okay, so this is what you're going to be listening to the majority of the time. I'll have something like this so you guys can look at this. Okay, so. First off, keywords and notes that we're going to want to take into account is the Earth's interior vocabulary. Okay, so we have two different types of evidence that we have determined on how our Earth is layered. Okay, direct evidence, which is what we would call rock samples. Now, these rock samples are samples of rock that we get very, very low in the ground. Okay, we can't dig down really, really deep. We can't dig down to the core. We can't dig down to the mantle. But we can see evidence through small rock samples that we get from the Earth's crust. Okay. Now, indirect evidence. This is an evidence called what comes from seismic waves. Those seismic waves caused by earthquakes can give us an idea of the composition of each layer. Okay. So now, one word that we also want to talk about is pressure. Okay. As we get deeper in the Earth's surface, okay, we keep going down into the crust, and we go down into the mantle. We go down into the inner core and the outer core. What's going to happen is we're going to have a lot of pressure on top of each of those layers. As that pressure builds up, we get heat, and we also get the intense pressure. Okay. So there's two different types of crust at the very top layer. So think of this, okay? The inner core is really solid. The outer core, I'm going to go over this again, but the inner core is really solid. The outer core is liquid, okay? And then in between, beyond that is the mantle, okay? We'll talk about that more. But also, then we have the crust. The crust is a very, very thin layer, okay? There's two different types of crust. There's continental crust, and then there's oceanic crust. Okay, these two layers these two crusts. One's continental in that it is mostly granite. Okay, mostly made from volcanic activity. Now that changes, and I'm going to talk about that a lot more as we go on in this unit. Oceanic crust is basalt. Okay, this is an oceanic crust, and we'll go into that in more detail. Okay, but it's very, very dense, whereas the continental crust is very not as dense. Okay, so it's more buoyant. Okay, so the mantle. Okay, there's 3 different layers. We're going to mostly talk about the lithosphere and the asthenosphere. There is another layer called the mesosphere, but we don't really talk a lot about that other than it's an intense pressure. Then we have the outer core and the inner core, and we're going to talk about those 2 as well. Okay, so let's go on to this here. Okay, so what you'll do is we're going to talk, I'm going to talk quickly about the direct evidence, and then we're going to talk about the indirect evidence. Okay, this video here will give you a little bit more detail, but I'm going to give you some detail as well. Okay. Direct evidence, that is evidence that we would find through rock samples, something that I could physically touch, okay? Indirect evidence is something that I can't touch it. I can't really see it other than using instruments, okay? So a seismograph is an example of a way that we can determine the layers. So if there's an earthquake that happens in a specific area, those go through the Earth's crust and through the ocean, and what ends up happening is that we can determine from one side of the Earth to the other whether there is liquid or whether there is solid objects in between the location of the earthquake and the seismograph. Okay, now I'm going to give you a little bit of detail other than the waves that we would talk about, the P waves and S waves. Okay, but I'm not going to get into a whole lot of detail with that. Okay. So, let's talk about the characteristics of the inner core. Okay, first off, it's solid iron and nickel. Okay, there are some other elements in there, but really it's basically iron and nickel. Okay, and so the atoms are so packed together. Okay, we're going to talk about atoms. The atoms are packed together and they can't move. Okay, the approximate thickness of the Earth's inner core is about 1,200 kilometers thick. Okay. So there's a picture here of the inner core and then the outer core. Okay, I would definitely keep. I would double check that every once in a while. Okay, one thing that I want to tell you is that the crust is also a part of the upper mantle, which we would also call the lithosphere. Okay, outer core. It's liquid iron, nickel, some oxygen, silicon, and sulfur. Okay, it is much thicker than the inner core. If I go back here, the inner core is 1,200 kilometers, and the outer core is about 22 kilometers thick. Okay, the movement, okay, of this liquid magma, so to speak, it's liquid iron. Okay, it's not really magma, so it's liquid iron, and so what ends up happening is that it is actually. Scientists believe that it causes the magnetic field in the Earth, on the Earth. Okay, now talk a little bit about that. Okay, there are 2 different magnetic poles, or there's 2 different poles on the Earth's surface. One is called magnetic, and one is called directional. Okay, and they are slightly different than each other. Okay, now apparently that magnetic field moves as time goes on. And the reason that they think it moves is because of the convection currents in the Earth's outer core. Okay? So we'll talk a little bit more when I talk about the mantle about what is the outer core. Okay? So what I want to do is I'm going to look at my video just to make sure it's still going, and then I'll be back in just a second here, okay? Okay, all good. Okay, here we go. So now the mantle, okay? The mantle is a very hot rocky material, okay? So the uppermost mantle is what we call the lithosphere. That's where the crust and the mantle kind of touch together, okay? And it's part of the crust, but it's also the upper top part of the mantle. Now, the asthenosphere. This is an important part of the Earth's crust. Okay, what's happening is the asthenosphere is below and is much hotter. It's still a solid though, but it acts like a liquid. Okay, so I'm going to give you a little bit of an explanation like that of that. First off, it's like a metal spoon. You take a metal spoon and you can kind of bend it and you can move it back and forth like this here. Okay, that's kind of the way the asthenosphere is. Okay, now the asthenosphere, what ends up happening is that it actually, through convection currents, even though it's solid, it gets really, really hot at the bottom. And then what ends up happening is that the outer core is heating it up. And as it's heating it up, those currents move up. Okay, and as they move up, they get further away from the heat, and they have what's called a convection current. We've learned a lot about this in previous lessons. Okay, now what ends up happening is that mantle makes the lithosphere move. Okay, so that's where we get the earthquakes and we get volcanic activity and the continents moving away from each other or closer together. Okay, we'll get into geological time later on, where we talk about the initial crust, where the Earth's crust was in one area. It's called Pangea. Okay, now it's a lot different. That's because of the movement of the Earth. Okay, and the movement of the Earth is because of the asthenosphere. Okay, so review real quickly. The asthenosphere is solid. It acts like a liquid. And the reason it acts like a liquid is that it moves through convection currents. And so what ends up happening is the crust, the inner core, and the continental and the oceanic crust move back and forth. Okay, when we start talking about continental drift and we talk about plate tectonics, this will be a little bit more understanding. Okay, so here's just an overview of what I just talked about. Okay. Okay. So now let's talk a little bit about the crust. Okay. First off, it's continental crust and oceanic crust. Two different types of crust. One is denser than the other, and the one that's denser is the oceanic crust. Okay. So it is mostly granite. It's light colored. Less dense, meaning that the density of a continental crust. So let's say two crusts were coming together. Let's say an oceanic crust and a continental crust. And we'll talk about this during the continental drift and oceanic plates lesson. What ended up happening is that the oceanic crust would actually go underneath the continental crust if they were moving together. Okay, so that generally is a review of this last unit here. What I'm going to end up doing is I'm going to do, I'll do a couple other videos, but this is April 13th, April 14th, and what you're going to do is I want you to take notes on what I just talked about, watch the video, watch my video, and then I will see you guys on the, I may do something on the 14th and the 15th, I'm sorry, the 15th and the 16th, but right now, I hope you guys get a lot out of this, and if you guys need to, you can obviously contact me through Canvas. Okay? Have a good evening. Talk to you later. Bye.